Hey everybody, I just wanted to say hello. Another morning is here, or another video is here, and we're working our way through December. Hope you guys are having some good earning weeks or some good home repair projects or whatever it is you're doing on your DIY stuff, whether it be working on your cars or your house. This is a little tool building thing here. Obviously that's my face on a blacksmith. And I'm not a blacksmith, but I did build some of my own tools, and I used torches and grinders and stuff like that. Those right-hand upstream oxygen sensors on those 5.4s in the late 90s, we had to replace a lot of those because the way that the thing was built whenever it was new, they had the air conditioner evaporator would drip on the oxygen sensors and destroy them. And so not only did we have to replace the oxygen sensor on a recall program, we also had to put a little special rubber thing that basically had a PCV closure tube with a rubber elbow on it. Then you're supposed to cut that tube and work that elbow over the evaporator drain and then direct the elbow so it dripped the water somewhere else other than on the sensor. And putting that thing on there was really hard because it was in a tight spot, but my buddy Donnie and I got pretty good at that. It was really kind of fun to do. Once you did a few of them, you could knock it out pretty quick. But this wrench right here, I would put that on the sensor, and then I would get the pry bar and put against, whichever side of this I needed to, and break that sensor loose, and I could screw it out with my fingers and screw the other one back in. But none of the oxygen sensor special sockets or anything worked very well for this, so I had to come up with my own way to do it. I bent this wrench for some reason or another. It seems to me like I was working on a lot of some particular kind of carburetor, and it had one nut that was really annoying to get to. You couldn't get on it with a socket, not even with a wiggler, and it was just, I don't know. And I basically bent the thing, and then I put this notch in the end so I could put a screwdriver in there to apply some torque, and that worked really good too. It's good to have this. These were proto wrenches right here, and I guess I probably should have used some cheaper wrenches, but at the time, my wrench drawer is not perfectly laid out in order like a lot of you guys. I mean, I've gathered my wrenches over so many years. They're just all different brands of wrenches, and they're all thrown in the same drawer. But anyway, if I had more than one 7/16 wrench, for example, like this one was, I would make a tool out of the one that I had. I used this right here. I used a piece of tubing and cut a socket and brazed it on the end of that thing. So, because some of those oxygen sensors, when you were trying to plug them back together, the wire harness connector was way up there. It was hard to reach, and you couldn't hardly get it to snap back in. And unplugging it was easy, but snapping it back in was a bear because there wasn't any space between the transmission and the tunnel. And I'd reach up there with this thing and hook it on that that oxygen sensor, and it would hold it while with my other hand I pushed that connector in there and until it clicked. If you didn't have that thing plugged together good, it might come unplugged, and then you got to come back. Now, whenever I was working with fluid piping and stuff, I always said to do this. We had this transmission flush machine. I've had it in other pictures on here. And we did this full fluid exchange on a 2004 Mercedes, and it did not have, of course, they weren't supposed to have to do that, but it wasn't shifting right, so we did it. But my kit, all of the different adapters that I had for transmission services with that flush machine, did not have an adapter that would work with that Mercedes. And so I basically got an aluminum line with one of these kind of affairs on it, and I got that off of there, and with those two O-rings on there, I managed to make a tool that I could connect my transmission coolant flush machine and replace all of the fluid in that Mercedes transmission, E320 I think it was, and it shifted great after we replaced the fluid, and that's all we did. We didn't do anything but replace the fluid, and it was supposed to be lifetime fluid, but you know how that goes. Now, I built these useful tools. I built test lights like this, lots of them, different. This is one of the ugly one I got in my box out there. But I'd drill a screwdriver out all the way down to where it exposed the back of this, and then I'd put a bulb in there with a spring, and I'd even fix it where you could screw the back of the screwdriver back on there. You see that little seam right there, and I'd have a little bushing in here. You know, might be a bolt that I drilled out, or it might be a you know, pipe nipple or something like that. But I'd sharpen the end of this off, and that way I had a test light. And I built these things for several people. I built a test light for one of this older used car mechanic that was over at the dealership. And I went back over there, I don't know, eons later, and he was still working there, and he said, let me show you something. He got that test light out that I had built him like 20 years earlier, and it still worked, and he had never even had to replace the bulb. But this was fun. I just, for the heck of it, I usually keep a lot of these momentary and push button switches, you know, the ones that'll latch and the ones that are just momentary. And what I'll do is build stuff with them, because I enjoy building stuff anyway. So I actually took a relay apart, got all the guts out of it, and I put this button on there, so when you mash this button, you were basically closing the secondary circuit. And that was just fun to build. I didn't necessarily need to use it a lot, but if you wanted to put that on there and mash that button, or maybe put a latching button on there, you could run your fuel pump, you know. Of course, that button needs to carry a few more amps if you're going to pull much of a load with it, so be aware of that, you know. Now I built this to test shock actuators, ISC motors, but I can't remember for sure all the details about it. I had a switch here, positive and negative and all that, but and I used an old power window switch on that. And whenever I would, this was the second one I built. The first one I built was basically had a rocker switch in it, and the rocker switch wore out. And then I used a couple of ISO relays that I put in there, you know, so that I was just basically triggering the coil to reverse the polarity and all that. I could have drawn a schematic of that, but I didn't do it. Anyway, that would enable me to just plug in and check to see if a reversible motor, like an idle speed control motor, or these actuators and shock absorbers and lots of other ones, if I wanted to, you know, take the computer out of the circuit and connect this, I could operate it back and forth, and in just a minute I'd know. This was an adapter harness I built for testing components on different vehicles. If you don't want your airbag blowing up in your face, you better disconnect your airbags, and you better put a dummy load in there, which would be like usually a 2 ohm resistor. And this was a homemade dummy load for Airbag diagnostics. There's a 2 ohm resistor in the heat shrink. And when you just plug that in, the system thinks there's an airbag there, but there's not. And even if it tries to light it off, it's not going anywhere. My buddy Donnie was working over at the Lincoln Mercury dealership before he came to the Ford place where we were. And there was a Thunderbird that had lit off its airbag on the car carrier, you know, while they were driving. They took it off at a dealership and they replaced the airbag, but they really didn't find out why it lit off. And so Donnie went and his buddy, it lit off another airbag, and so they, you know, on the carrier, so they got it into the shop, and so Rick, the guy that was working on it, was getting ready to dismount the airbag module, you know, the electronic box under there. And Donnie took the airbag off of the steering wheel and turned it around with the wires connected to it and looked at it and put it back on there. And about the time he took his hands off of it, Rick removed that module, and whenever he changed the angle on that module, that airbag popped off again in Donnie's face. If he'd had that thing in his hand backwards and it lit off, it would have probably killed him. You know, this is those little moments, you know, those airbags, you got to take those things seriously. I saw a video that I could have captured about somebody that took an airbag and put it in a sort of a pipe, and they put a bowling ball on top of it, and then they fixed it where they could light that airbag off so that it would propel that bowling ball. And it was like shooting a cannon. That thing went out of sight up in the sky. Now the scary thing about that is you don't know where a bowling ball like that's going to come down when you shoot it that high into the sky. You better do it in a big open field or something. But anyway, airbags need to be taken seriously, you know. I could go on and on about them. Now this was a cheap substitution for the two-wheel ABS valve on the 80s and 90s Fords. They had a 22,000 ohm resistor in there. The reason that was there was because when you plug that thing in, it would know it was plugged in. If the wires were broke or if you unplugged it, it would turn on the light. See, because that 22,000 ohm resistor basically would short the voltage away. So if there was something wrong with the wiring, or if it was disconnected, because of that 20. I could go into a lot more detail on that, but anyway, I built this. If I suspected that this 22,000 ohm resistor was open and that was causing that light to come on, I built this and I put a 22,000 ohm resistor in here, and I could just plug it in to the harness where the Rabs valve was, and if the light didn't come on, I already knew. See, I like this go no go test. It's real fast and easy, and that's what I did. Now this is a coil swap test. I don't know how many times I just would take some jumper wires and wire up an ignition coil, you know, to the circuits that were supposed to fire the coil. And just any kind of coil you can typically fire if you've got something that will fire it, like a module or even points in a condenser, if you know how to do it. And so on this particular one, I could connect a good Dodge coil that I had to a Ford and start the vehicle. One time, whenever my wife was driving a Tempo that I bought her new back in 1993, I was working on a go-kart with an old Briggs & Stratton engine that had points. You know, the points have gone from Briggs & Stratton engines long ago. My boys were going to want to ride this go-kart that my father-in-law had. And so I took the coil off of it, and I connected that coil to my wife's Tempo, just, you know, connected the wires and hooked it up to the ignition system, just like a regular coil, because that one had a distributor on it. And it fired up and ran. I said, okay, well, it's not the coil. And so I went to the place where you bought the small engine parts. And I said, I want some points in the condenser for this Briggs & Stratton engine. And they said, well, how do you know the coil's good? I said, well, I started my wife's car with it. And their mouth dropped open. They didn't have any earthly idea you could even do that. But an ignition coil is an ignition coil. Now, the difference between the oil-filled coils and these E-core coils is an oil-filled coil will handle a dead short, like on your DuraSpark systems. When you switch on the key, if you're not spinning it over, that DuraSpark system has got that the trigger. We got that thing dead short to the ground. In other words, the negative feed going to the primary. It's dead short to the ground on a DuraSpark. You cannot do that on a E-core coil, because if you ever dead short that thing to ground and hold it there for any amount of time at all, it burns that coil up. It didn't burn up an oil-filled coil, but it would burn up one of these. So you got to know the difference on that. Anyway, a coil is a coil, basically, is what I'm trying to say. You hook that coil up, it ought to make a spark, and that was part of what troubleshooting ignition systems. This homemade relay tester I built out of junk would test most ISO relays, both normally open and normally closed positions. You know, it would turn this light off and that one on when you push the button and all that. But it didn't load the relay significantly so you could reliably test the relays with it. And I had it fixed where you could either test this kind of relay, plugging it in here, or one of these ISO relays, plugging it in here. You know, I couldn't make one with all the different, you know, but they make relay testers that are really expensive. I just built this one out of junk. This box right here, I think, if I'm not mistaken, was a wiper governor or something that I took the guts out of and used that. I used to grab all these little plastic boxes whenever and pull the guts out of them. It's an infrared tester box. Now, I built this to test Jeep Cherokee infrared remotes. And whenever you would push the button on this remote, that red light will come on, but this might not be putting out anything. And that's back, you know, infrared remotes were in the 80s on Jeeps and all. And so I went to Radio Shack and I bought a detector, and I put a little LED here, and I got a battery in there. And so whenever this detector saw a signal, then it would blink this light. Of course, this is a pulsing signal, you know, and this light would pulse along with it. So this LED would close the circuit between the battery and this LED here. In other words, this optical, you know, detector thing. And anyway, that was just built with a project box from Radio Shack. But let me show you something. I didn't at the time have digital cameras. I didn't have a cell phone. That stuff wasn't out there in the 80s. At least I didn't have one. But watch what happened here. I was going to do this with my with these glasses I'm wearing, these Meta glasses, and demonstrate how when you take a infrared remote and you look at it and you mash the button, you can't see the infrared, but your phone can see it. Well, I didn't think about the fact that my glasses can see it too. But look at this difference how this is. I pulled the trigger thinking I wouldn't be able to see it. My glasses can see it though, but you can't see it with your naked eye. But these glasses can see it, and recorded his video. And watch there, see that? You can actually, it can see that infrared even in normal light, but your eyes can't see that typically. You might be able to turn all the lights off and see a little something, but this is the quickest way to test a remote, even a one at home, if you got one that's not working. I used to buy all kinds of different factory style connectors so that I could fix stuff right. I always wanted to fix it right, just like it was factory, just like nobody knew you'd ever been there. I did that when I was installing theft alarms and all kinds of stuff. And so I always wanted to run the wires so that nobody would ever know that somebody had been there, or they'd think, wow, look what a good job this person did. Because I didn't make a lot of money installing that kind of stuff, but I really wanted to make sure I did a great job of it. And, having the right connectors, and this is just one example of that, these weather pack connectors, that's a part number. I don't know if that's still a good part number or not, but I'd buy them, keep them in my box, and I could fix them things right. Speaking of which, these Jeeps, Grand Wagoneers, had a DuraSpark module on it that was a no-name brand. And they would crap out and fail just like some of the DuraSpark ones did when they roll. And so I said, well, I'm going to make this better. And so I would take a DuraSpark module, one of these really good solid Motorcraft ones, because it still had a blue grommet, and I would cut these off, and I would put these connectors, I'd take the connectors off of the old module and put new terminals in there, and because I had the male and female terminals in the boxes and all. And I would actually adapt one of these for one of those Jeep Grand Cherokees to make it better. Making it better is what we're supposed to do anytime we can, right? Now this is fun stuff. This was the very first electronic tool I ever built back in 1984, working at the Lincoln Mercury dealership. And only the little week 3 system, this map baro sensor right here, and you can still buy these doggone things if you're trying to restore something. You pull 10 inches of vacuum on this port right here, it would put it in self-test, and I had these lights connected to a little connector they had. They never built a tester for it, but there was a little connector there that was connected to your thermactor air bypass and diverter solenoids. And these things would go back, forth, they would do a little dance, and then when they started switching together, you would count the code. This was all the codes they had right here. See that? And so I would get on there whenever I was working on one of these at the dealership. I bought a project box to put some lights in there, and you hook it up to the battery, and then you hooked it up to that little connector over there by the tab and tad solenoids, and it would go boo, 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 boo. And then it was when they start, like once again, when these lights started switching back and forth together, then you knew you had you knew what your code was. And it would see, and you could just go right to the problem a lot of times on one of these old deals. This was a box I built for EEC 4. I decided I'm going to build me something for EEC 4. And so I did this. They told you originally, as I remember, to use a voltmeter and watch the needle sweep, which was stupid. So I said, I built this box right here, and I even had a connector where I could disconnect the harness from it. And this is your old EEC 4 VIP test connector, and this is how I wired it up, And if you made it switch so that the self-test output was basically going to a buzzer and a light. See that? That's when it's going to flash the codes out. Okay, and so what I would do here is I would put ground. There's 5 volts right here. When you're short that to ground, this goes into self-test, and it'll flash out your codes. Now you got to be watching. It flashes out fast codes. Later when they had the new generation star tester, it would read the fast codes, and I kind of quit using this. But I used this for years, and this was something I built at Radio Shack and all. It had a little buzzer here, and it would go whenever I would know if it had codes in there, because the fast ones would come out and go bzzz, and buzz, But I really enjoyed the new generation star tester when it came out. But anyway, this was something I built, and I used the stew out of this thing, and I built one for somebody else for, I think I charged them $40 or $50 to build it. All right, this anti-theft story right here. This was one that sat there in the parking lot, and if you let it sit there in the parking lot, it was a brand new car, nobody ever bought it. Ever so often the theft alarm would go honk, 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 honk for 3 minutes, and then it would quit. They couldn't sell the car like that. So in this, there was no codes, no scan tool that was going to connect to the theft alarm like it is on the later model stuff. This thing right here was dumb as a brick. It had a theft alarm control unit. It had a switch from the hatch, the hood, and each door. And if the thing was armed, like when you lock the doors, it was armed, anybody that opened any of these and grounded that switch would, I mean, the switch was, you know, normally closed, and whenever you raised it up, I mean, I'm sorry, it was normally open. When you open the hatch, it would close, and that's when it would light off the alarm. And so I said, well, this is something, I mean, this thing might sit out here for 6 hours and not do this, and when it did it, whatever that short was only there just long enough to light it off, and then for 3 minutes it would honk and all that kind of stuff. That was its timeout, and then it would quit doing that. Well, I came up with something. I said, here's what this thing looked like. The horn and the lights were an output anti-theft unit. There was the driver door, passenger door, hood, and rear hatch, and they would ground, you know, whenever they were, you know, closed. They were, like I say, they were basically normally closed, and whenever you closed the hood or the hatch, it opened the switch, but when you opened them, it closed the switch. And so this is showing them all closed. I said, okay, I got to take this intermittent and turn it into a hard fault. I need something to record that. We didn't have no scope at the dealership or nothing at the time. So I built this little box here and went to Radio Shack. I bought some 1/4 amp fuses and a little fuse holder thing that I could snap them into. Put it in the box so that whenever all of this was like it was supposed to be, and these switches were open, which I didn't draw them this way, all of these lights would be on, right? But if anything closed one of these switches, it would blow the fuse, and the light for that respective one would go out. See? You can see how this is wired up if you look carefully. And so I left that thing sitting in the service bay, and there were some guys working late that night pre-delivering cars and all, and I said, if this thing lights off its alarm, do not walk over here, don't touch it, just put up with the noise, and I need to look at this tomorrow morning. So I left that thing laying there undisturbed all night long, and when I came in there the next morning, they said, yeah, it happened about 7 o'clock last night, and we didn't touch it. And one of these lights was out, and it was the one going to the hood. That was the one that went out. Popped that fuse whenever that short, and it turned off that light. And what I did was I ran another wire from that switch. I clipped the existing wire out, which went all the way across the radiator support, back through the driver's side, across there under the dash to that module, which was on the right side. I clipped that out, and I managed to run a wire right through the harness straight into the car, because it was a harness going straight into the car from about where that switch was. And so I replaced that, I bypassed the original wire. I don't know where it was shorted. See, the running another wire is smarter than trying to find the short if that's the only wire in the circuit. And so that's what I basically did that time. And it never gave that problem again. But how would I have found that if I had not built this little box to turn an intermittent into a hard fault? That was what I did. Now this Escort 4EAT transmission one shift right, Kevin rebuilt it, no joy, he asked for help, and the Ford Probe had a similar transmission, but it had a special box Ford provided that you hook in line, and it would turn on lights to give you the, you know, the shift pattern and all of that, and even had a little chart. I said, well, I need to build something like that for this Escort because it didn't have the same connectors or anything else as that Ford Probe, but it was still a 4EAT transmission. And the odd thing about the transmission solenoids on this and on the Nissan RE401 is it basically has them hardwired to ground, and it sends power to the solenoids, which is the reverse of what you would expect. Also, the airbag system on the Continentals was like that. It was hardwired to ground. It would send power to the actuators, which was just odd. Anyway, when I saw how that was wired up, I built him a box with $40 of stuff from Radio Shack. Now let's go to the chart. So we had the chart here. Now this chart is really nice, but try looking at this on the fly whenever you're trying to figure out what's wrong with one or what's going on or what's, you know what. And I says he had already rebuilt it and everything. He knew everything was right inside the transmission, but it was still giving exactly the crazy slamming shifts, jumping gears. I don't remember all the details, but it just was terrible. And so I says, all right, what we're going to do here, we're going to build the correct light pattern. We're going to build a box with lights like I was talking about. And so I built that. And so we actually used that chart to create ourselves a little light pattern thing. So when it was in first, these two should be lit up. You know, you'd think it would be shift solenoid 1, 2, and 3 would be on in that order. That ain't the way that works. They're all mixed up. So this right here in neutral, shift solenoid 3 is energized. In first gear, 2 and 3 are energized. In second gear, 1, 2, and 3. In third gear, 1. But see, we used the chart to build this. In other words, I built that so that we could monitor what these solenoids were being told to do. And it turned out he had a bad engine controller, powertrain control module. And once we put another one of those on there, it ran like a top. But it took this procedure that I came up with to figure that out. And that's the only time he ever had to use that box for anything. I borrowed it from him one time when I was working on a Continental airbag system. I mean, you know, air suspension system. And it had the same. They were 4 actuators, and they were, you know, and it worked really handy for figuring out what was wrong with that Continental too. But I don't remember what was wrong with the Continental. Now I won that Ford Best Ideas contest with this transmission thing. 3 times I won this thing. It was a lot of fun, and there's 3 different ideas I sent up there, and they sent me a $100 check and these little plaques and all that kind of stuff. And you know, Tom Wagner signed these things. You see his signature right there. You know, he was a distinguished guy. You can look him up. But this is this was back in the early 90s, February 5th, 92. It's before I met my wife. October 9th, 1991. April 24th, 1992. And then one of the students over at the college was changing out a U-joint, and he busted this vise. Just kept cranking it down. You know how U-joints, if you don't have everything right, they won't go all the way in there where you can put the clips in. And he literally destroyed a vise. I never saw another student break a vise the way this kid did. I think he just used a cheater pipe and all that kind of stuff. Now here's an ancient snap-on spark tester that I had at the college. I actually owned one of these too that I bought. Back in the late 70s, I think I bought one of these from the snap-on tool guy. And believe it or not, there's a little capsule in here that when you didn't notice, there's no connection here. But when you stuck that down in there, they said don't use for electronic ignition. I don't know why. I guess they was afraid it'd shock you or something. But whenever you stick that thing down in there and back probe the boot without punching a hole in it, this would flash orange if you had spark, which is pretty slick. You could also use it for a scratch all or an ice pick or whatever. But there was one of these at the college when I went over there. This was that brand new one at the college. It had never been used, and it was on my desk for a long time. So when I was at the college, I took that picture. I don't know whatever happened to that thing. Somebody probably took it and sold it on eBay. These are a collector's item now. You can look that up. You can still buy them, but they usually cost $40 or $50 because you can't get them anymore. Snap-on took them out of their catalog and replaced them with these other kind of inline spark testers. Well, Christmas is coming. This is the deep south, what it looked like Christmas looked like here. And this is what Christmas looks like for some of you guys that are north of here. And I hope you enjoy the snow. We don't really get a whole lot of snow around here, but last year we got some. Hope you got something out of this, and I will see you guys next time. We've been here nearly 30 minutes, and I hope you lasted till the end. See you later.